Okay. Okay, yeah, we're live. Okay.
Okay.
Oh my goodness. I'm so glad that everyone else is off this morning. It makes me...
Yeah, me too. It makes me feel a little bit better. Oh.
Okay. Mercedes, it's all
Okay.
yours.
Oh, okay. I guess we could start with number 6.
Okay.
Start with part 2, section 6.
Yeah, part 2, number 7.
So, yeah, 7. That's what I meant.
So we're in lesson 6, part 2.
Yes.
Okay.
Yeah.
Okay, right on.
And we're on number 7.
Yes.
And we have to randomly select 5 of the 30 salaries, and I guess altogether we have to compute our mean.
Yeah.
Isn't that what it wants? Okay, so I forgot. I need to go get my calculator. Hold on, I'll be back.
So basically we all just need to pick 5 numbers, different numbers.
Just
Okay.
5 random numbers. That's what we did.
Okay. Have you already gone through this part?
No, we just got the numbers.
Oh, you have your 5 random numbers and she has her 5 random numbers?
Yeah.
Do I need to pick 5 random numbers?
Yeah.
Okay, I'm back.
Okay, I've picked 5 random numbers, so now I just need to get the mean, correct?
Yeah.
Yeah, so now we have to get the mean of all those numbers.
So I should add it up and divide it by 5, right? That's what we're doing. There's so many means now that I just have to be like, okay, this is just your basic mean, right?
Do we have to compute, what I'm wondering is, do we have to compute just our mean, or do we have to compute everybody's mean together?
We do our mean because if I remember right, is that right? We say, yeah, it says what is the mean of your sample, and then we compare, correct?
Oh, okay.
So,
Okay, so I have to just do that then, so I'll do that.
Okay. One, 2, 3, 4, 5. Okay.
Okay, that is a big number divided by 5. Okay, so I got my mean.
What's your mean?
It is, hold on, I need to, 1 second.
I don't know if I might calculate like this or not. I might have to.
Okay, I got 51,320.
Yeah, my calculator did not like what I just did. So, okay, I think, there we go. I think I got 36,384. But I'm just going to do it really quick because I forgot to put it in parentheses, which I have to on my calculator. Sorry.
That's okay.
You're fine.
What did you get, Mercy? Are you still going?
I got 185,000. I don't know.
That's what I got. I got 181, but if you don't, I think it's because you didn't put it in parentheses if you're using a graphing calculator.
I was just using the calculator on my iPhone. I'll try again, though, and see.
Well, all of them will be different, and if we look at the numbers up above, I mean, we've got some pretty large numbers up there. So if you had mostly 50,000 as your...
Well, mine's 43,360, but I originally had 181,920. It's because I needed to do parentheses.
Oh.
And then do divided by 5, so it knew to add those up first and then divide by 5. So that's my mean is the scrap paper it is.
Okay, yeah. I got a different number now.
Okay, what did you get?
I got 45,000.
Okay.
And I got 43,360. Okay. So the mean of so we need to write down the mean of our samples.
And what did you get?
Okay. I got 45,000.
45,000.
Okay, Elizabeth,
Okay.
what did you get?
I got 51,320.
Okay. All right. So then we go on to B.
Okay. Yeah, so B, it says, this graph illustrates the sampling distribution of the sample mean, there are 142,000 combinations of the 30 salaries. Draw 5 time. Okay. This graph represents the distribution of all the possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A. So is it just our sample then?
Yeah.
So mine is going to be, I didn't print this out because I just have it on my computer.
Okay.
So mine will be right. Wow, I'm on like the higher end. Oh boy.
Yeah, let's see here. I'm 2 deviations away, I guess, if you would say, from the mean.
That's what I
So
am.
yeah, between 42 and 43.
I'm at the very top. So I'm way out of the norm.
Yeah, you're like in the 95, 97.
Yeah, I'm in the 95, 97th percentile of life.
Okay, so then does your sample mean appear to be unusual? Explain why you think it is or is not unusual.
I don't think any of ours is because it's still in the, I don't know.
We're still in the range of it.
Yeah.
We're still in the bell shape.
Yep.
Okay. And then compare your mean from question 7A to the means obtained by the 3 other. We did that. What do you notice? In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred.
So, well, if we were to just take our 3 means, our means are, it creates a bell-shaped curve. So,
Yeah, because one is lower, one is middle, and one is at the other end, correct? So we're
Yeah.
So we're all normal.
okay.
We're normal.
Yay. I wonder what the mean of our means would be. Like, I wonder if it would be like the mean of this. Does that make sense?
So, you're saying if we add up our means and then divide it by 3?
Ooh,
Yeah.
We should totally do it.
Okay.
Let's do it.
We're becoming statistics.
I guess. I mean, we don't have to, but we might as well.
Okay, mine was 45,000.
Oh
That was
crap! I
me.
just cleared. Dang it.
Okay, so parentheses.
And you divided it by 3.
Well, if
Yeah.
you're going to find the mean of that, yeah.
40. I got 46,560.
Which is almost, I think that is close to the mean.
Yeah, that's basically close to the mean, because the mean is 4,600.
Huh.
Wow.
That's cool.
That is cool.
Learn something every day. Okay. So let's move on. Are we on number 8 now? Are we good with that?
We're good.
Number 8.
So the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample of 10 students taking the GMAT. What is the shape of the distribution of the sample means for all such samples?
I have normal because it says normally distributed.
Yep, that's what I got.
Yep.
And I think it would also be because it's such a high sample size, right?
Yeah.
I think with
Where in the text it said, oh, this might be section 7, but
yeah, I think.
I don't know what I'm trying to say. I mean, it's where it's like, oh, what's the name of it? Central limit theorem? Is that what it is?
That's what it is.
Yep.
If the sample size is large, the sample mean will be approximately normally distributed.
Yep.
Okay, cool. All right, and then B says, how do you know that the distribution of the sample mean has this shape? Was normally distributed. The parent population is normally distributed.
That's why, yeah, because the scores are normally distributed. So when it talks about that, the mean population is the parent population, correct? That's the
Right. Yep.
everybody. Okay. Yeah. So then, what is the mean of the sampling distribution of sample mean scores for all such samples?
Which is isn't it just the mean that it gave us of 529?
Yeah, that's 529. Yep.
Okay, and then D, what is the standard deviation of the sampling distribution of the sample mean scores for all such samples? So we have to take the standard deviation, which is 113, right?
Yeah.
Okay.
And we have to divide by the, what is it?
By the number of students, which is
Yeah.
10.
Basically, the square root, I believe, of your n or your random sample that you're doing.
Mhm.
And then what'd you guys get for that?
35.734.
That's
Okay.
All right.
Basically, this is just taking a random sample of the sample. We're breaking it down even more, correct?
Right.
Right.
Because before we learned how to just get the basic random sample, now we're taking a sample from that sample.
Mm-hmm.
Okay, yeah.
It's so much nicer when we talk in a group because I actually understand it.
I know. Did you guys do okay on the quizzes? Because I know we had that rounding thing. Did you guys end up rounding?
I did do okay on the quizzes. I got a 100% on the first one, and then the second one, I don't remember what I got. I think I got like one wrong, and I don't remember why it was.
Well, on one of them, I know we need one, but on one of them I sent that email because in our group discussion, I don't know if you got that email.
I saw that. I did, and I took the quiz before I got the email.
Is that the one you missed?
Yeah.
That was the one I missed too. Yeah.
Did you miss that one too?
Yeah.
Because I went
Well,
through.
the others I did fine on, so.
I think it might have been. I think that was
So
the
you
one I
were
missed.
supposed to round it up because I noticed that it said round up there at the top of the quiz.
Right.
So I was hoping you guys had rounded. So
I'm
okay.
pretty sure, I don't know. I can't remember which one it was that I got wrong, but I saw that email after I took the quiz.
I read
and I was
through it
like,
again and I was like, oh no! I've got
okay, so do we want to discuss this quiz for this one, or do we want to move to the next section?
Well, if we move to the next section, the thing is, if we do a group quiz, I don't know if we're going to have problems again with Mercedes not hearing.
That's a good
I know
point.
how to fix that now. It's in the settings. I don't know why it just turned it off, but it's in the
okay.
settings, and I can turn it back on. Yeah.
Okay, so Mercedes, it's up to you. You get to call it.
Well, in 7 it does review Chapter 6, so it could help us with Chapter 6. But I'm fine just going over Chapter 6 again. I mean, going over the quiz with 6 too. I don't care. Whatever you guys would rather.
Why don't we just keep this broadcast going and let's discuss section 7, and then let's do quizzes.
And that way we can also pull up anything we need. Okay.
Right. Okay, so let's move on to section 7.
Okay. This one was a little tricky. Did you guys?
I'm gonna need help because I was so confused.
Yeah, there's a few of them that I'm like, okay.
Yeah.
Question marks. So, Robert, hope you're
I
on.
was so confused. Like I had to pull up the answer key and like read along. And I was so confused. I honestly was like, okay, this isn't working. Just trying to figure it out on my own.
Yeah.
So
Yeah, I
have the answer key up, and I'm like, okay.
okay. Does anybody have the actual chapter up? Do you want me to pull that up?
I do have the chapter up, but yeah.
Okay, so we've got resources.
Yep.
Okay.
Yes.
Just making sure. Okay. All right. Shall we?
Yes. Okay, hold on. I'm getting my chapter. Okay, there we go. Yeah, I was getting pretty frustrated last night. My poor husband was just like, okay, calm down. You need to take a study break. Okay.
Yeah, I was like, forget this. I was like, I'm just going to have to figure, anyway, yeah. I was like, my brain is down.
My brain was done. So let's go through it together. So part 2, it says, suppose paracomputing sold an average of 45 P phones per minute in 2011. Yes, the means they sold 23,652,000 P phones in 2011 with a standard deviation of 10. And they looked at their P phone sales data and determined that they are normally distributed. Sample of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X bar, or X?
Normal.
Normal.
Tells us.
Normal. Okay, and then for 5, somebody else want to read that one?
Samples. Oh, go ahead, Mercedes.
You could go. Okay. Samples of size n equal 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X? And I said normal.
Normal.
Yeah. Okay. The sample size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is less than 40?
So it's, the answer is supposed to be Z equals -1 probability. So that's equal to about 0.16 using the 60, 80, 90, 99.7 rule.
Did you use the applet on that?
I was not sure how this was working.
Me neither. I was, yeah.
So I got the fact that it was -1 because it is, if you draw yourself the little bell shape, you can figure out that it would be 1 deviation to the left because the mean is 45. So if it's to the other direction, -1, correct?
Okay, yeah. That makes sense.
Okay, so, and I figured that the answer, I had to look at the answer, you know, I kind of had to walk through that through the answer, and if I remember correctly, if you put -1 in the applet, if I did that, then I think that's how we got the
That's right.
0.016.
That's right.
Does that make sense?
That makes a lot more sense, yeah.
So it looks like here they're doing deviations. It gets a little trickier further on, but that was like, oh, okay, so what is the probability? Well, I didn't see any formula in the homework or anything, so when it said -1, so I drew my little thing, and then I was like, okay, it must be based on this, they're using it off the 68, you know what I mean, they're using that rule.
Yeah, which is using the applet, so.
How we were supposed to know that off the top of our heads, I don't know.
I know. That's why I was like, I did not get this. I am so confused.
So that's when I was like, try to look at the answer and be like, okay, -1, that's the only way, and that's when I was like, okay, I'm going to draw a little bell. And then you put it in the applet. And so then in number 7, it says a sample size N4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is greater than 35 and less than 55? Well, 35 and 55 is the 2 deviations away.
Okay. Oh, that makes sense. Oh.
It's -2, and 55 is +2 deviations. But I might be wrong, but that's the only way I could figure that out. And then when you put it in the applet, you get the 95 percentile, which is where 2 deviations is, correct?
Yes.
Right.
Okay. That makes sense.
Okay.
I did not even think of using the applet, honestly. Like, I was like, I just have no idea, but that
because
makes a lot more sense.
Remember the videos, this was the applet.
Yeah, I couldn't get the videos for number 7 to work for, I think it's just my internet though. So I was going to try again later today.
But if you have the lesson thing, if you have your lesson manual up, you can go to the applet and just see.
Is it in lesson 7? Is the applet in lesson 7?
If it's in your
No, the
main-
applet is in the book.
So if you have your lesson 7, if you have the actual lesson up, do you have the actual lesson?
Yes.
Then you can go to the main page, and then you can just go to the applet.
Oh, okay.
And it's under
I did not know that. So
yeah, it's under resources, and just go to applet. Do you see it now? I think it's like the second or third one down. Under I think it's
resources.
Yeah.
It's like one.
I found it.
So that's the applet. So if you put in the 2, and if you put in 2, see if you get the
2 for the Z-score?
yeah.
Okay. And what side do I highlight? The middle?
You're going to highlight the 35, so you're going to have to highlight the 2, I believe the 2 sides, correct?
Yeah. So it's 9.9545.
That's it, yep. And that's what the
Okay.
was. So go back in there and then put in 1. Put in -1 on the other one. And you're doing less than 40, so you're going to have to do the left-hand side. And tell me if you get the .016.
Just the very end?
Just the left side, yeah.
I got 0.1587.
0.15.
87?
Okay, now click on the other. Click it one more time in the middle.
Click the middle too?
So it's only one, so maybe, see what happens.
With the middle and the left side, it's 0.8413. With just the middle, it's 0.6827.
Okay. So then that's not how I did the number 6 then. That's what I needed to find out. Okay, give me 1 second because I'm going to pull up my... Okay, let me pull over here. I had it up, but I had to shut everything down when I was having my issues. So we might need to come back up to that one then, so I can see the answer thing or whatever, how I worked it out. I literally, by the time I was done, my brain was just like ready to explode. So
I see. It's rounding up to 0.16 because it right now the answer is 0.1587.
Yeah.
So they rounded up to get the 0.16.
Yep.
Okay, yeah. So is it? But I think in the answer log it's 0.016. So maybe
No. In the answer it's 0.16.
oh, that's my tired error. Okay, then that's what they did. They just rounded it. Okay, so that is correct then. Okay, great. Now I feel
So then,
better.
how do we know when to round and when to not? Because I don't know why they
Always round.
always round. Always? Okay, I'll always
That's
round.
And I asked my husband, who's kind of a math brain, and he says unless it tells you otherwise, like unless you have to use that full number, you like when you're doing something algebraic or you're doing your data for taxes, you know, just certain things like that, then you don't round. But I noticed in all of his thing, he said round to the third number. Right? Did you guys notice that too? He said round to the.
Yeah.
So basically, I think they just seem to always round to whatever decimal point you're supposed to be at.
Okay.
So.
Okay.
Okay, so now we're good there. We got that one.
Yes.
Yep.
Okay. So like I said, I don't know if I would have known. I would never have known to do that if I hadn't looked first
Right.
Mm-hmm.
to have the answers to walk through. I don't think I would have been able to figure that out on my own, which is kind of a bummer.
You did better than we did. So.
I didn't. I mean, I even had.
Okay, should we go on to the next one?
Okay, so for number 7. Yeah.
Oh, number 7. Okay.
Shoot, that's wrong. Sorry, I'm typing in and I'm not paying attention. Okay, so go ahead. I'm getting into my view.
It's okay. You want to read it, Mercedes?
Yeah, number 7, right?
Yep.
Yeah.
Okay. A sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is greater than 35 and less than 55? So since
So
there's
this
two,
same rule is using the 68, 95, and 99.7 rule.
yeah, so we're going to use the applet again. We're going to put
We have
negative
30.
2. So it's going to be 95, 45.
Yep.
Right.
So it's 95% or 0.95, right?
Yep. Mhm. Okay, so then number 8. The sample of size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that X is greater than 41 and less than 94? So the thing is that we're putting -2 into the applet and then 2, right?
Now I think in the answer log, I might be confused on either this one or the next one. But if you look in the answer log, I think they're saying, I could be wrong, but go ahead and put it in because I think you're going to get the 95% again.
Yeah, you do because it's still the middle
answer log
range.
has it at 97.5, if I remember right, or maybe it's the next one.
Let's see. In the answer log for number
8.
they have 95 point. Yeah,
They do?
0.95.
Okay.
Yeah, 0.9545.
Okay, good.
So it's the exact same thing.
Mm-hmm.
It's the exact same thing.
Yep. Because the numbers are still. But see, I thought the numbers would have been one standard because, but this is the one that threw me off because between 35 and 45 is 41, which sits in the one standard deviation.
Mhm.
Mm-hmm.
That makes sense?
Right. Yeah, I was a little confused to the end how it's just greater than the mean. Basically, both numbers are greater than the mean, so that's why I was a little confused for 8. But I guess because it's still two probability numbers, that you still put 2 in there.
Okay. Oh, so they're doing it more from the numbers per se than the deviations.
Right. Because if let's say
Yes.
it just said is greater than 49, you would just put 1 or negative, or yeah, you just put 1, and that's how you get it because there's only one probability number to do it against.
I see what you're saying.
Okay.
Okay.
But I don't know if that's really how it works because what if they gave us more numbers than just 2? Would we just have to find the mean of that or something? I don't really know.
Let's not go there.
Okay.
I was like, let's just not go there.
But I think we'll eventually know how to do that. But I see your point. So you have to make sure you're doing it right.
I'm not sure if that's really how it. Right. I'm just not really sure if that's really how we're getting what number we're using in the applet.
Yeah, I don't know if we're doing this correctly. That's just how I was able to figure it out. But I don't know exactly how they're coming up with the -2 for sure.
That's
what I'm wondering now.
How are you doing it? How are you doing it, Anna? Do you know? Or yeah, because I don't know how to do it.
The only thing was with that -1 when I did the 6. I was like, okay, well that's to the left of -1 standard deviation, but I don't know if I'm right. And then the second one fit in correctly with the 2, so I was just trying to, that was the only way that my brain could figure it out to get that answer. Is that's what they were doing. Now that may not be correct, and I think we may need to go into our chapter a little bit more.
Does
maybe
8
or whatever.
work that way too?
Well, no, because see, that's the thing. In 8, 41 and 49 sit in the first standard deviation.
So it's not, you wouldn't be using your -1 and 1.
Yeah. See,
right?
So that's where I was confused. So it made sense until I got to, it's like, that's how I did until I got to number 8. Then number 8, I got a little bit confused because I was like, okay. So it has, I think it has, because it comes to the 95%, they're obviously using the 68 rule, but I'm not sure exactly how they're deciding what's 2 and what's -2. Does that make sense?
Yeah. Let's see if it's in our chapter at all.
Yeah.
And I don't remember seeing it in the videos. Do you, Elizabeth, anything about that? Now, are we supposed to, and then I thought, well, are we are we supposed to use that new program where it drops all the little squares?
Right.
Oh
the
yeah, that's what I
sampling
was wondering too. But I don't think that would help us at all with this one.
Right.
Because that was
It doesn't give us a number at all.
So if you look at the sampling distributions, the review of sampling distributions is the part here with the applets. So I was like, okay, we're using, obviously, applets are involved, correct?
Right.
Okay, so here's the probability involving a mean. So then I thought, well, then maybe what if we're supposed to, so then I tried doing it the other way where we try to find the z-score with the 10 divided by 4. So I took the, does that mean I took the original problem, which was you have your 45, and then I think I did 40 minus the 45 divided by, your standard deviation is 10, so then we have 10, and then I was like, okay, well then, is it the observed 40, so then do I, but it says is less than 40. Does that make sense? I was like, okay, well, divided by...
Here was when I got confused with this whole thing when I was reading is, okay, where, and it might be just plain and simple, where is the 10 coming from? Like, I honestly, oh wait, there it is. I just answered my own question.
So
Never mind, we're good.
that we could find in section 3 on chapter, well, no, I'm on chapter, I don't know. Well, in lesson 6, I think it says that you just have to find it by getting the standard deviation of the sample means. Right?
Okay.
Yes?
But,
You know,
but if
I think this question actually pertains to probabilities involving a mean. Like, I think it really does, because I think. Let me read through this question. I wonder, hold on, sorry.
Okay, so I set the standard up for number 6, right? I set it up how you would usually do it, which would be the 40, the observed. Okay, so you have 40, which is the, oh wait, this is what I did wrong. The n is 4, not 40. So if you do the 40 minus the 40, maybe this will make a difference. This might be, maybe we're supposed to be doing this way.
I think it says after finding the z-score, we could use the normal probability applet. So we do find the z-score for it.
So oh my goodness, that's what we're supposed to do. So if you do 40 minus 45 divided by 10 over your square root of 4, you're going to get -1. And then when you put the -1 into the applet, then you will get the 0.16. That's what we're supposed to do. So I did have it right the first time, but the first time I didn't understand the applet aspect of it. Because I have a problem with that.
Makes sense.
Hallelujah. I love groups.
Find the z-score and then okay, that makes sense. I get it now.
So that's the -1. So if you do the 40 minus the 45 divided by 10 divided by the square root of 4, right, our formula, you're going to get -1. -1 in the applet, then you're going to get 0.16.
Correct. Sounds good.
So that's why my original thought of the 2 is probably does make sense, but it's just not going to give you it exact enough. Does that make sense?
Yeah, that makes sense.
Yep, that makes sense.
So then we have to go back through and do every single one of these, and then when they have the 2, the probability is greater than 41 or less than 49, I'm thinking you probably have to do 2 problems.
Yeah, well then what do we do? Do we define the z-score of both of those?
Yes, yes. I think you find the z-score of both of those and you add them together. You add your applet amount together. So do you want to try that and see? You want to do number 7 again first? We need to do number 7 first. Okay, so it's the same idea of number 7. So then we have to do 40 minus 35, correct?
Yeah.
Divided by 10 over the square root of 4, and then you have to do it again over here with 55 minus, 40 minus, sorry, what is it? Is 40 correct?
Yeah.
40.
Oh, it's not
55.
What is the 45? So you have to do, sorry, it's 40 minus 35 minus 45 in this one. 35 minus 45, and then
Wait, where did
55
you
minus
get your 45 from?
from the original problem. 45 is your mean.
Got it. Okay, I'm so confused.
Okay, yeah, I
I'm
was.
talking out loud while I'm figuring this out. I apologize. I'm like,
No, it's
okay.
helping
okay.
actually.
No,
Okay.
it is really fine. Okay, yeah, it is 45. I was like, wait, where?
So
I'm so
you
confused.
35 minus your 45 divided by your 10 over your sample mean, which is your sample of your samples, which is your 4. Then you have to do 45
Right.
minus 55, right? Okay.
Right.
So as
It's
long
a
as sometimes
35,
I get
45
my
because that's less than, and then we take the 55 minus, or then the 45 minus the 55. Wait, is that right?
I don't think so because we're going to put it in the applet, and so it depends on where you put your blue code on the applet, where you click on the applet.
It would be the middle of your
So-
applet because
Yeah, so
greater
35
than.
minus 45, correct? Divided by, tell me if I have the order wrong, because that's where I sometimes screw up, my mean and my 2, okay, divided by 10, divided by the square root of 4 equals -2. That's correct, so that's my -2. And
There
then
we go.
45, okay, so we are using, because I thought that was weird, I'm like, why aren't we using this formula more? Okay, 45 minus your 55 divided by...
Divided by the standard deviation. Okay. I get it.
This is making a lot more sense now, actually.
Yes. Well, I've got -2 on both, so one of these is supposed to be a positive 2. So I screwed that up somewhere, but one of these is supposed to be a positive 2. So then if you put it in the applet, then you're going to get your 95%. Because we've
That
already
makes
done that.
sense.
We've already...
Yeah.
Because in all of these, you don't add in any of the formulas. You always subtract. So what I did wrong was I did 55 is supposed to be 55 minus 45, and I had it switched, and that gives me the positive 2.
Oh, okay, yeah, that makes sense.
That's what I did wrong. Because that's what I do sometimes is my brain starts moving, and I just got those two mixed up. So that's what I did wrong there. So then we have our -2.
The positive, you do the 55 minus the 45, which is
That's
the
what I
value minus the dot, and then you do 35 minus the 45 because it's the value minus the, what is it, the mean? Is that what it is?
Yep.
Okay.
So then we would do it again, one. We would get the 2 and -2 again, remember, because we already saw the answer part on that, and then we would get the 95% again.
Mm-hmm. Okay,
Then
so
go ahead.
for number 9, it's the sample size is larger. It's
Yep.
25 instead of 4.
So we would set it up.
Go ahead.
So then what we would do is instead of the square root of 4, we would write square root 25.
Root of 25. Yeah, it's the exact same thing, just the square root of 25.
Yeah. And then we would have to put it in the applet. The only thing is you got to hope you do your applet right.
Yeah, and make sure you shade the right areas too.
The right areas, that's where it gets me too. I know on a quiz I'm going to be like, I hope I'm shading the right area on the exam. So I feel good about that. I'm glad we figured that out.
Yeah, I feel a lot better.
That's where I was really confused.
So I'm sorry that I led you guys. That was the only thing I could think of. I was like, well, but then when I got to 8, I was like, no, that's not it.
At least
So-
you have sort of an idea.
That we figured this out.
Mhm.
He was probably a little worried there. Okay. So,
You probably would. Yeah, you're probably gonna watch this and go, "Oh my gosh, a bunch of goofballs."
Well, fast forward, just keep fast forwarding. Okay. So,
Okay.
number 10.
So number 10.
Okay. Pair Computing sold an average of 40 p-phones per minute, a mean of 40 p-phones per minute in 2010 with a standard deviation of 12. And they looked at their p-phone sales data and determined that the distribution is right skewed.
Okay.
So then number 10 says sample of size n equals 4 are taken from the right skewed 2010 sales data. What is the shape of the distribution of X? Of the mean? Right skewed.
Right skewed.
Yeah. And then it says samples of size n is 40, n equals 40, are taken from the right skewed sales data. What is the shape of the distribution? Did you guys get this?
Approximately normal.
That's what I got, approximately normal.
Yeah.
Okay. Because it's such a big sample, correct?
Right.
Yep.
Right.
Okay. Then on number 12 it says, is there a theorem that justifies your answer to question number 1? And what is
Central
it?
limit.
Yeah. So that's why.
Sorry, I totally jumped the gun on that one.
You're like, woohoo, I know that one. Okay, 13, the sample size n equals 4 is taken from the right skewed 2010 p-phone sales data, and you want to know the probability that the observed mean is less than 35. Can you compute this probability using the normal probability applet with the information you have? I don't know where my phone is to turn that off. Sorry, you guys are going to hear ringing for a minute.
Okay.
I have no, because it works with normal distribution. I don't think it
That's
only works with normal distribution, because it's the normal probability applet.
Yeah, I agree.
Okay, yeah, that makes sense actually.
Okay, and then 14 and 15, yeah. Those just have question marks next.
Yep. Okay. Oh man, my brain is starting to hurt. Okay. Okay. Sample size of n equals 36 is taken from the right skewed 2000 p-phone sales data. What is the probability that the observed x is greater than 36.5?
So we need to find the
Sorry.
Z-score again,
Oh.
and then plug it into that.
Yep.
Even though it's right skewed.
Oh, that is kind of a good point.
Right skewed, it only works with normal distribution, but the sample size is large.
So can we use the probability applet on this?
Well, we just answered number 13 was no, that we can't. Because it said, can you compute this probability using the normal probability
So
output?
this was on the video, I think. So let's go all the way down in our lesson to see if it talks about when it's not, I think it talks about in the video when it's not a normal distribution.
Okay.
I could be wrong, but does that sound familiar, Elizabeth?
Yeah, I would. Yeah, it does.
He does a
I'm
little
trying.
section in his video. Because this one is all the normal, and
Normal
then
curve. Here's the. Ooh. Oh, that's not it. Never mind.
okay, just kidding. All right, okay, go ahead.
Just kidding. Sorry.
Okay, making inferences. Okay, that's just
Yeah, that part.
this review. Okay, let me go to the video part and see really quick. I will see if it's in lesson 7, part 2, and I think he has it where we can just click on a section. Yeah, when population is not normal.
Okay.
So, I watched it, but we have to recap of what he said because I can't remember.
Well, not only that, but, okay, it says, suppose the mean internet usage is 10 hours and the standard deviation is 2, the distribution is right skewed. Suppose a random sample of 50 students were surveyed concerning the internet usage of the sample of 50 be considered a large sample. What is the mean, the standard deviation, shape of the distribution of the sample mean? Basically, he just did, oh, it is a little different. He took the 10 hours, which he took the sample mean, and he divided it by the square root of 50. So then basically what we have to do is we have to take what is the sample size is n, and let me see. I don't know where he got the 2. Okay, so I'm going to have to play the video.
That's okay, go ahead.
did he get the 2 from doing the actual problem first, and then he took the answer, and then did it again with the 2?
Yeah, maybe he did the z-score of the original.
The 2 is the standard deviation. Suppose the mean internet use of Idaho students is 10 hours, and the standard deviation is 2. So what he did, he took the standard deviation divided by the square root of the sample.
So the sample size, the square root of the sample size?
The problem is the standard deviation is 12. Okay, and they sold, okay, so the standard deviation is 12, right?
Yep.
Okay, and then what is the probability is greater than 36.5? So
you're going to do...
am I going to do 36.5 at the top?
I think you're going to do 36.5 minus 40,
12?
right? Or 40 minus...
Look at this sample. He doesn't do that formula.
Oh, he doesn't?
No, he says the sample is your population mean equals your population divided by 10 hours. So basically it's 0, your O, your standard deviation, divided by the square root of n.
Okay, so just try it for, just put 36.5 and don't use the 40 at all.
Okay, so I'm going to try that.
It was the standard deviation divided by what was it?
Divided by 12, because 12 is your, no, oh, I'm sorry, your standard deviation, oh, that's right, I have it flipped. Your standard deviation, I'm sorry, your standard deviation in this one is 12, so 12 is at the top. And it's the square root of 36.5. We can try that. Does someone have the answers up, just so we can see if we're
12 divided by the square root of what?
12 divided by the square root of 36.5. That might be wrong.
That does not sound right.
What did you get?
1.97. So there is a 1.97% chance that it's greater than 36.5. What does the answer say?
It's negative 1.75. So why don't you try plugging 40 into the problem and see if that changes the answer?
I'm also going to put this in parentheses because sometimes that makes a difference in my, just to make sure that's not because I'm doing that.
Okay.
Same answer, so that's not the issue. So then you want me to do 12 divided by the square root of 40?
No, I would do 30. I would do 40 minus. No, I do 36.5 minus 40.
Divided by 12?
But his formula is different on the screen. You want me to hit play on this to see?
Yeah. Okay. So what is the formula? It's the standard deviation divided by what?
By the standard deviation by the sample size, your n. The standard deviation divided by n. So the sample size is 36. That's what I'm not reading my problem correctly. So 12. See what happens if you do 12 divided by the square root of 36.
36. Our standard deviation, the sample size is 36, and our standard deviation is...
Because that's what the standard deviation is on this one. Oh, wait. This is it's a different problem. I keep going and think and look at the original one. Okay, yeah, standard deviation of 12. Okay, so 12 divided by... Okay, so 12 divided by the square root of 36. No, that's 2. Are you trying it the way you're thinking, Mercedes?
Yeah, it's not working. I don't know. Okay.
Okay, so your sample size is 36, and we know that the square root in this one is, our standard deviation of this one, if the right skewed, okay, so.
Oh my gosh. Okay. Percent deviation and our sample size.
Okay, so he has here,
And the standard deviation divided by the sample size. 36. So 36 is going to be on the bottom. And
if you go to the video, Elizabeth, you can see what I'm talking about. If you go review lesson 5 when population is not normal, he has this formula right here where he has 50 random
is it
surveys.
less than
Yeah, if you go into lesson 7 videos, go to part 2 and then click on review when population is not normal. And that's what we're looking at right now. The population is not normal, right? Because the distribution is right skewed. Am I correct there?
Right. You are correct.
Okay, so 0 is, in this, he says there's 10 hours, 2 divided by 50. So let me do his problem and see what he's got going on here. 2 divided by the square root of 2.83. That's how he did it.
Now what I'd like to do is I'd like to find area. of
Sorry, it's
probability.
playing.
That's fine. Yeah, it's just the very last minute and 48 seconds. But you can click on the one screen. Distribution of sample means when parent population is not normally distributed. So then sample size is 36. We know that I get 2, and the answer is not 2. That's the only thing I can think of. That's the only formula I could think of. Okay.
He takes mean minus hours. What part are you at in the video? What number?
It's part 2, the last one you can click on. It's 1.48 or whatever. Open. Because here it says on 8, what number are we on? 14. I'm looking at the answer too to kind of see if what we're doing here. See, it has a probability of negative and then a probability of 95.99, so we have to use the applet, correct?
Yeah.
Yeah.
We have to put the z-score in. So do we need to do the z-score then?
Yeah, well,
You tried the
score.
That didn't work for you, Mercedes, when you tried the z-score where you did 36.5 minus 40 divided by 12 over 36. Did you try that?
Here, do it again and I'll put it in.
It's 36.5 minus 40 divided by 12 with the square root of 36. I'm just confused by that video.
Divided by 12, right?
12 divided by the square root of 36.
Okay.
I get negative 1.7.
Yeah, that's the answer. So that's right.
That's what I got.
Okay, so then that video is not helpful.
Unless I just dropped my pen. Hold on.
Because in that video, it just shows you do the 2, you know what I mean? You do the 2, and then you get that number. So then do you have the applet up, Mercedes?
Yeah, I do.
Can you put the negative 1.7 in and see if we get the probability of 0.95?
Yeah. 1.75, right?
Negative 1. Well, I didn't get 1.75. I only got 1.7. Did you get negative 1.75?
Let me see what the answer is, and I'll see. Well, I didn't really get one, so.
Oh,
yeah.
you know what? It's because I did 36.6, so it's negative 1.75.
Okay, and then is it in the middle, greater than, less than? What do I shade?
Oh, I think it's 6. Yeah.
Greater than.
It says greater than.
Okay, so I get 0.0401.
No, try it. Tablets, more places.
If I do the middle, oh, greater, okay, yeah, it's 0.9599.
That's it.
Okay.
Okay. So it's basically that same thing. So then basically on number 15, we're going to have to do the two problems probably and then add it together. We're going to have to do the first problem, then do the second problem, and then figure that out because there's two separate problems, right? Like we did before.
Right.
Right.
Mhm.
Okay, so then we get to do 37.5 minus 40 over 12 divided by the square root of 36. These make you sound smart, don't they? And then there's 42.5 minus 40, 12, and square root of 36. Okay, so do you have one of those? Are you doing one of those, Elizabeth?
Yeah, I've got one right now.
Okay, I'll do one. And then you'll be the applet. Does that sound good?
Yep.
Which one are you gonna do, Anna?
I'm doing the 42.5. Is that what you're doing? Which one are you
Nope,
doing?
I was doing the 37.
Okay, that works out great then. Were all my numbers right? My setup?
Yeah, 42.5 minus 40 divided by 12.
Yeah, that's correct. I got
with
1.5, which is right, and then you should have negative 1.25.
Oops, with a 2.5. My bad. And then what was the bottom part? It was 12 minus the square root of 36, or is it 12 times?
It's 12 divided by the 36. You always do the 12, the standard deviation divided by the sample size.
That's right. That's right. Okay.
Okay, so can you put in negative 1.25, 1.25 into the
Applet?
because it's going to be the same. Both of them are going to be the same.
Okay, yep. And then
Yep.
I shade the middle, right? Because it's between those two.
I think.
Okay. Then I get 0.7887.
Okay, just do one at a time then. Do one, because you have to do one that's less than, is between 37. So what is the probability? So I think you have to do the 37, you have to do the below one, and then the above. Because the answer is 0.1056. So I'm thinking you might have to do them, you click the shade on one of them and then do the higher one on the other.
Okay. Yeah. But when you plug them both in, because one's greater and one's lesser, it's the middle, and you get the last thing that it says on the answer is 0.7888.
But that's the answer to the actual problem.
Right.
I see what you're saying. So basically,
Let me see if I just put in 1.
if you put in 1, did you get 1.056?
0.056, yeah, and then, yeah. That's what I get for both of them. So then if you just do the middle, which is both of them together, it's going to be the total answer.
Which is easier, because here the formula says 1 minus 0.1056 minus 0.1056, and you get 0.7888.
Which I guess is just another way to show you, just another way to figure it out with
Manual.
But I mean, you're using the applet anyway, so you might as well just do the middle.
Okay, I am going to make a note of that, though, on my things.
But yeah, it's good to know if you let's say you didn't have access to the applet, and they just give you the answers of this. So just 1 minus those two numbers, and then that would equal, yeah.
Which makes sense because you're subtracting it from the whole.
Right.
Okay. Hallelujah. That's it. So where I got confused with that video where it says when it's not normal, I was like, but then I wasn't getting the answer, so we really have to just do the whole formula. Okay.
Yeah.
Okay. Now we get to do the quizzes. Okay. So are we done recording?
Let me do it. So hold on. Okay.